Sounds good.
Muy buena. Bueno, pues hola a todos, muchas gracias por conectaros. Esta es una nueva sesión internacional de PUG Barcelona. Y hoy tenemos un invitado de lujo. Nikola Ilic está dando trainings por todo el mundo, ahora me estaba contando, acaba de volver de Houston, luego Oslo, no sé, este hombre va por todos lados, sabe un montón de todo, tiene un blog acojonante y está ahí, es súper buena persona. Y es del Barça, que también está muy bien, y que esperamos que pronto pueda venir a Barcelona en persona y pueda darnos una sesión ahí a todos. Pero nada, hoy nos va a hablar de Direct Lake, que es un tema no menor, que vino con Fabric y que tiene cositas que no son muy intuitivas a veces y estoy seguro que nos dará bueno, un buen repaso a todo ello, ¿de acuerdo? Recordad que los que queráis escuchar el audio en español, que será mi propia traducción, pues tenéis disponible la reunión del Meet, que estaba especificada en el Meetup y creo que se ha compartido también en el chat. Y nada, ahora le voy a dar una pequeña intro a Iván en inglés y ya para que empiece, ¿sí? So, Ivan, thank you so much for taking time for us. We are really happy to have you here. And I'm really looking forward to this session. I have tried a bit with Direct Lake, but I feel like I don't really get it. So please tell us all about it so that we can leverage this in our project. So I'm gonna turn.
Thank you. I'll try, since this is 60 minutes, I'll try to share as much as I can in 60 minutes. Yeah, but of course, if you need more information, feel free to reach out to me. So whenever you need. So yes, and thanks for a nice introduction. I understood a little bit. You told some bad words about me, but yeah, I don't mind. Kidding aside, so I don't speak Spanish. I would love to, but yeah, thanks for having me and thanks for inviting me to present for Power BI User Group Barcelona. It's an honor to be with all of you tonight, and I see a lot of familiar faces. So hi everyone, and yeah, maybe I can start sharing my screen. Okay. So as Bernat mentioned, we are going to talk and explore a little bit about Direct Lake in Microsoft Fabric and Power BI. Don't worry, this session is not trying to sell you Direct Lake or stuff like that. So we will just try to analyze how this new feature works behind the scenes and in which scenarios, based on this internal work and internal events that are happening in the background, in which scenarios you might consider going this way. Few sentences about me. My name is Nikola. I'm originally from Belgrade in Serbia, but for last 8 years, I live in beautiful city of Salzburg in Austria, where I work as an independent data platform consultant and trainer, focusing mostly on Power BI and recently, of course, when Fabric was announced, also with Microsoft Fabric. Before that, in my previous life, I was SQL developer and then BI developer, so I worked with all these traditional Microsoft's BI stack, like SQL Server, analysis services, integration services, reporting services, and so on. I guess you all recognize the location of this picture. So it was taken last year in March. It was game versus Valencia, one of the last games at Camp Nou, and I'm looking forward to coming to the new stadium. I heard they will finish it in somewhere in December. So yeah, I'm a huge Barca fan since '90s. So it's like 30 years of my relationship and my love with Barca. But we are not here because of Barca and Camp Nou. We are here because of learning something about Direct Lake. And here is a short introduction about topics that we are going to cover in next 60-ish minutes. So we'll take a brief overview of Power BI storage modes. So pre-Fabric era versus Fabric era. Then we will also examine in more depth how Parquet and Delta format play a key role in implementing Direct Lake solution within Microsoft Fabric. Then we will analyze some core concepts in Direct Lake that will help you to understand how this thing works under the hood. Then I'll explain the difference between two types of semantic models. So far, before Fabric, we had only semantic model, like a semantic model. Now we have two types of semantic models, default and custom semantic model. We will examine some benefits and some limitations of direct lake storage mode, and I'll try to share my perspective when possibly it makes sense to go this way and to use direct lake. Of course, there will be a few demos along the way, so I want to show you those different concepts in action in Power BI and of course DAX Studio. So I guess you all know, probably you know if you work with Power BI, that what this function will return in DAX. It will return today's date. So why I use this on this slide? It's because everything is subject to change, especially in terms of Microsoft Fabric. So since Fabric was announced last May at Microsoft Build, so let's say a year ago, I can't tell you how many changes were introduced and how many changes we are seeing each and every, not month, but basically every week we get some new features, we get some changing of functionalities and so on. So things that I'm going to tell you about Direct Lake are relevant as of today. Please keep that in mind, and if you're watching this session in a few months, don't throw tomatoes on me, because things change in the meantime. Keep in mind that in Fabric world, things are changing very, very, very quickly. So just a short, brief overview about Microsoft Fabric, just in case that someone of you haven't heard, but I think there are just two possibilities that someone haven't heard about Microsoft Fabric in the last 6 months or last year. The first possibility is that you were in coma, and the second possibility is that you don't have an internet. Other than that, if you follow this space, Microsoft Fabric is all over the place and literally everywhere. So essentially, that's a software as a service solution for Microsoft, software as a service platform that consists of multiple different components. The key component from a storage perspective is one lake, and I'm emphasizing this because we will talk how data is stored within one lake, within Fabric, so that direct lake mode can work in this way that it works. And also there are different processing options for working with this data that is stored in one lake. So one lake, you can think of it as a one central storage location for all the organizational data. There can be only one lake within Fabric tenant. So previously, you could have go and create multiple different storage accounts. Now it's just one. It's one lake and that's it. And all your data lives there. Nevertheless of the format, nevertheless of the size, structure, and so on, it's always in one lake. And then we have, as I mentioned, those different services for processing data that is stored in one lake. For data integration, usually we use Data Factory Experience. I will not go and explain, but think of it as bringing data from somewhere and integrating it into Fabric, or moving data across different Fabric items. Then under Synapse Experience, we have different options for processing data. Data engineering experience is based on Spark engine. Data warehouse experience is for traditional SQL developers. Data science, for machine learning workloads and data science workloads. Then we also have real-time intelligence. This was called up until recently real-time analytics. It was also part of Synapse, but as I told you that things are changing, I had to change this slide, even though I did similar presentation like 2 months ago. So I had to change it because it's a new experience now in Microsoft Fabric called real-time intelligence. Our favorite tool, Power BI, is still there. We will examine what changed in Power BI in Fabric times. And finally, we have Data Activator, which is still in public preview. That's the only part of the platform that is still in public preview. And this one will soon go under real-time intelligence umbrella. So as of today, it's still like a separate experience, but soon you will find it under real-time intelligence. I forgot to mention, but if there are any questions throughout the session, feel free to interrupt me. Bernat, if I may ask you to just monitor the chat in case I miss something, and yeah, feel free to ask a question. And of course, in the end of the session, in the end of the session, we'll still have time for questions and answers. Okay, so that was like a high-level overview of Microsoft Fabric as a platform. Now we are going a little bit narrower, and for you, me, as Power BI professionals, the main question is, what should I do now in times of Microsoft Fabric? Relax. I mean, 90% of things, or even more than that, are absolutely the same. And if we start looking at from perspective of user interface, Microsoft Fabric was built on top of existing Power BI user experience and user interface. So you will find yourself in very, very familiar environment. So don't stress too much about changes that are coming with Microsoft Fabric. Most of the things and most of the approaches are still very, very, very relevant. So if we talk about Power BI architecture before Fabric, the most common way of doing things with Power BI implementation and recommended way of doing things, that's what we learned throughout the years, is import mode. And this is a typical workflow when using import mode. So you import the data into the instance of analysis services tabular. This is this cube. So that is, think of it as instance of analysis services tabular. And from there, Power BI reports always sends DAX queries and retrieves the data directly from this cube. Okay, so in order to have fresh data in your semantic model, you need to go back to data source and refresh the data which is stored in analysis services instance. This approach has its greatest benefit in providing really blazing fast performance because data is stored in memory, in cache memory. But there are certain downsides. The most obvious ones are data duplication, because you're basically creating a copy of your data from the data source in analysis services instance of Azure Analysis Services. And of course, data latency, because in order to have the latest data available from the data source here, you need to refresh semantic model. And then there is another option, direct query, which solves these shortcomings. Namely, it solves data duplication and data latency because we are not moving any data from the original data source. Data lives in original data source before, during, and after the query execution. And your users will always have latest data available because data is retrieved at the query time. And that's great. However, I'm sure all of you who use direct query at least once will agree that performance is, well, significantly worse than with import mode. Let's be nice and kind, and let's put it that way. And here is where direct lake mode enters the stage, trying to exploit benefits and overcome downsides of both import and direct query modes. In a nutshell, it's a kind of a hybrid of import and direct query. There is no data duplication, there is no data latency, because Power BI will read the data which is stored in one lake delta files directly. But this time with the performance of the import mode, or let's say very close to the import mode, because data is stored in the same way as in the proprietary format in Azure Analysis Services, which is suitable for fast data retrieval. And we will examine how this data is stored and why Power BI with Direct Lake can work that way that it works. So before I show you how Direct Lake works and why I consider it like a very special thing in Microsoft Fabric, let's first understand what are the prerequisites for using it. First and most important, you need either Fabric F capacity or Power BI Premium. So P, one of P SKUs in Power BI, to use and Fabric workloads enabled on this Power BI Premium workspace. So it's either F or P capacity. With other licenses, Direct Lake is not available. Then you need a Fabric Lakehouse with SQL endpoint. This is necessary because in case your queries cannot be retrieved using Direct Lake mode, they will fall back to a well-known direct query mode. We will examine when this happens and what should you take into account. And also either warehouse. So you can use Direct Lake on both Lakehouse and warehouse. Next, data must be stored in Delta tables. So if your data is in some other format than Delta, such as Parquet or I don't know, CSV or JSON, no Direct Lake queries are possible. And finally, we have one more, it's a not hard prerequisite, meaning that Direct Lake will still work even if Delta files are not V-ordered, but you should then expect performance degradation. And now you're probably scratching your head, what on earth is V-ordering? Don't worry, I won't bother you with heavy technical details. Simply said, it's a Fabric-specific way of additionally optimizing Parquet files when writing data into one lake. And all Fabric engines, no matter if you use Spark, if you use a SQL engine, if you use Custo, whatever engine you use, by default, all files will be written with this V-ordering applied. Now let's dive directly into a lake full of Parquet and Delta files. And let's examine one of the Direct Lake prerequisites in more depth. So I told you that you can use Direct Lake mode only with Delta tables, only with Delta format. So how data is stored in one lake? Not like this. This is what we are taking one step back, or maybe two steps back. And what you see now on your screen is how traditional relational databases are storing data. It's a so-called row-based storage where data is stored as a sequence of rows. And this is great when you need to write the data. It's super fast. But if we talk about analytical scenarios, let's try to imagine some common questions that your business users may ask. For example, looking at this table, how many balls did we sell? Or how many users from the USA bought t-shirt? Or what is the total amount spent by customer Antonio Grant? Or how many sales did we have on January 2nd? And so on and so on. So you get the point. And to be able to answer any of these questions, the engine must scan each and every row, something like this, from the beginning to the very end. So to answer the question, how many users from the USA bought t-shirt, the engine has to do something like this. Essentially, what we need just an information from two columns: product, so we are interested in t-shirts, and country, we are interested how many t-shirts we sold in USA. But the engine will scan all 5 columns. This is not the most efficient solution. I think we can all agree on that. And then, like maybe 12, 13 years ago, or maybe more than that, but approximately 12, 13 years ago, column-based storage was introduced and built into analytical databases. So how column store works? As you may assume, the approach is totally different compared to row-based storage. In this case, each column is a separate entity. That means that each column is physically separated from other columns. And going back to our previous business question, the engine can now scan only those columns that are needed by the query, product and country, while skipping scanning of all unnecessary columns. And in most cases, this should improve the performance of analytical queries. Okay, so that's nice, but the column store existed before Parquet, before Delta, and it still exists outside of Parquet world as well. So what is so special about Parquet format? Parquet is a columnar format that stores the data in row groups. Wait, what? Wasn't it enough complicated even before this? Don't worry, it's much easier than it sounds. So let's go back to our previous example and depict how Parquet will store this same chunk of data. And before we look into this, I want to introduce two very important concepts in analytical queries, and why you will understand why these concepts are especially important in terms of delta and parquet storage. So in online analytical processing scenarios, we are mainly concerned with two concepts, projection and predicates. Projection refers to select statement in SQL language. That means which columns are needed by the query. Back to our previous example, we need only product and country columns, so the engine can eliminate scanning of all the others. And then we have predicates. Predicate or predicates, they can be one predicate or multiple predicates. They refer to the where clause in SQL language. So which rows satisfy criteria that we defined in the query. So it's not just about the columns, it's also about the rows that satisfy criteria. In our case, don't forget, we are interested only in t-shirts. So the engine can completely skip scanning this row group 2, where all the values in the product column equal socks. So I want you to realize the difference between various types of storage in terms of the work that needs to be performed by the engine. If we go back to row-based storage example, to answer the question, how many t-shirts did we sell in USA? The engine scans 5 columns and 6 rows. In classic column-based storage, it's 2 columns and 6 rows. And with column storage with row groups, it's 2 columns and 4 rows. Obviously, this is a super simplified example. On 6 rows and 5 columns, you will not see any difference in performance. But usually when we deal with analytical data, those are really huge tables that can go over like a few hundreds of millions or even billions of rows. So this difference can be really significant. And that's why Parquet became de facto standard for storing the data in the last few years. And Microsoft made a big decision to go all in on Parquet and Delta. We will explain what is Delta and what is Parquet. If you hear me using both terms interchangeably, it's almost the same. Don't worry. So Microsoft went all in with this format. Of course, things are now expanding with additional open formats that stores the data in a similar way. But at this moment, it's still Delta only from perspective of Direct Lake. Now I told you all the great things about Parquet, but can it be better than this? Yes. So with Delta format, essentially that's Parquet format on steroids. And when I say steroids, what do I mean? What do I consider as a steroid? Versioning of Parquet files, storing transaction log. So all the changes that you make to your data are stored in transaction log. And then you can track all changes. You can do point-in-time analysis and so on. So Delta is nothing else but adding additional layer of logging the data, of logging the changes that you made to your Parquet files. It's still Parquet. It's a group of Parquet files, but with this Delta log information on top of it. So this is how it looks in one lake. You see I have multiple Parquet files stored here. So all of these are Parquet files. And then I have Delta log, which keeps all the track of all the changes that happen to my data, which is stored in Parquet file. And sorry, 1 second, I forgot to turn on my favorite tool, which is Zoom It. So this is how Delta and Parquet work in synergy. This is a folder. So when you open Delta log folder, you see here, when you open Delta log folder, this is what you will see in there. You will see a bunch of different JSON files, each of them representing a version of the specific file, of the specific Parquet file. And then if you scroll down, you will see that the last one is, in this case, one with number 8. So that's the file that engine will scan because that's the latest one which contains the most relevant data. Of course, there are certain opportunities and options to see how data change in Delta log. I don't want to bother you too much with that. If you're interested, there are great resources I can share with you after the session. So going back to Microsoft Fabric, 2 main artifacts that we use when we work with Microsoft Fabric are Lakehouse and Warehouse. So just a short introduction from the point of Power BI semantic models. Whenever you create a lakehouse in your Microsoft Fabric tenant, you will get also by default provided two additional items. It's SQL Analytics endpoint, and it's a default Power BI semantic model, which is by default already in Direct Lake storage mode. And then you can build on top of it, you can build your custom semantic model. I'll show you in a few minutes in a demo how this works and what is the difference between these two. In warehouse, there is one difference, but essentially it's just a small thing. You don't see a separate item for a SQL Analytics endpoint because it's built in. Oh, I made a mistake. So here it should say a warehouse, not lakehouse. So apologize about that. So here, this is a warehouse. And again, we have default Power BI semantic model, but as I said, SQL Analytics endpoint is already built in within a warehouse. And what I was talking about, let's go to my Fabric tenant. So here I am, and this is my lakehouse called CMS_LH. So as I told you, two additional objects were created out of the box for me when I created lakehouse. It's SQL Analytics endpoint, and it's a default semantic model. If you open a lakehouse, you will see here on the left-hand side all the tables that exist in this lakehouse. Under tables, this is a managed area, and here usually you store your data as a Delta format. I say usually because in theory you can also save other formats in tables area, but for Direct Lake it's only Delta that's supported. Under files, you can keep all types of different files, whatever you want, and this is an unmanaged area of a lakehouse. I can switch from this view in lakehouse to SQL Analytics endpoint, and then I can also use SQL language to query the data from a lakehouse. If I go to reporting tab, two options are available to me, or let's say at least two options, to manage default semantic model and create a new semantic model. If I choose new semantic model, this is going to create a custom semantic model. Remember, I told you there is a difference between a default and custom semantic models. So new semantic model creates a custom model. This one lets me manage the one that Fabric automatically created for me. So if I click on manage default semantic model, you get some warnings about falling back to direct query and so on. So default semantic model, you cannot change its name, at least not from here, but you can define which tables and views you want to include in this default semantic model. So under manage default semantic model, you are changing the tables and views that are used by default semantic model. In reality, you don't want to use default semantic model for your business reporting in your organization. Why? Because it's not so flexible. It doesn't support most of the operations that you can do on custom semantic models. So default semantic model, I sincerely hope and pray that they will hide it by default. So it's going to be there, but I don't really see any like a real life use case in production environment of a default semantic model. Then if I click on new semantic model, here I can define a name. So I can call this one Power BI user group Barcelona, and then I can define in which workspace I want to save it. All workspaces that are assigned to my Fabric capacity are available, and I can choose which tables I want to include. So let's include, I don't know, those 5 and click confirm. So now in a few seconds, hopefully, you never know, but soon we should see this new semantic model in our TP600 playground workspace. Let's wait for a few moments. If there are any questions while we are waiting, feel free.
Actually, yes, we do have one from Fernando. Can I buy different FSQs for different capacities under the same tenant, therefore only one lake? That's the question.
Yes, you can. So you can buy essentially same as with PSQs. where you buy the number of cores. It's similar here with capacity units. You can buy certain number of capacity units and then split them. So if you buy, for example, I don't know, eight capacity units, which is F8, you can create 4 F2s in theory. Okay, so let me go back to my workspace, and here it is, Power BI User Group Barcelona. So this is my custom semantic model, and from here I can create a report. I can choose to auto create a report, all the different options that exist. So I can create a report and do whatever I want with my columns here. Please keep in mind that as of today, again, I need to insert this disclaimer. As of today, you can manage your semantic model in direct lake mode only from web UI or with tabular editor. So you cannot manage semantic model from Power BI desktop. You can use Power BI desktop to connect to this model and build a report on top of it, but no changes are allowed. So you cannot create relationships in Power BI desktop, nothing. It needs to be, you cannot define role level security. Everything needs to be done here from web UI, or what I suggest, of course, is using tabular editor, because then you have much more flexibility and functionalities available. So this is a difference between custom semantic model and default semantic model. In reality, you want to create custom semantic model and use custom semantic model for your reporting purposes. Now, how this, it's not a magic, but yeah, I like to call it sometimes a magic, how this architecture of direct lake works in the background. The trick is that Parquet format is a very similar to the way how Power BI stores data internally in import mode. When you use import mode, Power BI leverages Vertipack database, which is in-memory columnar database. So Parquet stores the data in a very similar way to how Vertipack stores the data. And that gives a possibility to Power BI engine to read the data directly from those Parquet files, from those delta tables. What happens is that once you create your semantic model, it's initially empty. So there is no data in it. Unlike with import mode, so when you create an import mode model, physically data lives in that semantic model. With direct lake, no data is in Power BI. Data is physically in one lake. And then once you start querying the data, Power BI pulls this information, pulls this data from one lake and loads it into a memory, same as with import mode. Now, a few things to keep in mind, a few things to consider when you start working with direct lake storage mode. First question, and that's the one I get very often from people learning Fabric and learning about direct lake mode, is what is happening. You saw in previous case, I've added 4 tables from my lakehouse. I added 4 tables into my custom semantic model. What happens if someone creates a new table, a 5th one? Will it automatically become a part of the model? It depends. So let me show you on what it depends. So if I go here and then I go to my SQL Analytics endpoint and open settings, there is a setting for default Power BI semantic model, which says sync the default Power BI semantic model. This is by default turned off, like it's now. So whenever someone, your ETL process or someone adds a new table to a lakehouse, this doesn't automatically go to your default semantic model. You need to do 2 things: either to turn this off, to turn this on. So in that way, it will be, your model will be automatically updated with the new tables, or you need to manually add the table, open the dialog window for managing semantic model, and manually click the new table that came into the lakehouse. That's what happens if we consider new tables to the model. But what happens if we have a new data within the table that already exists as part of our semantic model? So that's another possible scenario. In this case, this option to refresh the data is by default turned on. So that means if I go back here and go to my semantic model and open, I think it's in settings, yeah, refresh. So keep your direct lake data up to date. This means for existing tables that are already in the model, if there are new rows coming, your ETL process inserts data, I don't know, every 30 minutes or whatsoever. So if you keep this option turned on, what will happen every minute? I think Power BI will generate queries to one lake table, check the data, and bring the latest data, bring the latest metadata into direct lake semantic model. You can also decide to turn this off. In this case, again, you need to manually refresh your semantic models. This one helps you or enables you to get this automatically handled for you. So this is another setting or another consideration to keep in mind.
Wait a minute.
Yeah.
But you said that the data stayed on the one lake. So, but you need to load it somewhere? How does it make sense?
Be patient, my friend. P is for patience. We are coming to this right now. So
thank you.
Yeah, no problem. So the question that Bernard just asked, what happens? I mentioned data stays in one lake. That's true. But the question is there a refresh process then in direct lake semantic model or not? Remember, in import mode, if we want to have the latest data, we need to set our refresh, schedule refresh or whatever, incremental refresh, whatever, but we need to physically go to the data source and pull the data and load it into Power BI semantic model. Here, the process that is happening with direct lake is different. And it is called, this is, I think, not official name, but it's usually referred to as a framing, this process of refreshing data in direct lake. How does it work? This is my lake house. This is my Delta table, and I have 4 different files in that table. So my semantic model, let's say as of today at 1938, it contains data from these 4 files. And this is like a frame. Okay, think of it like a frame. I framed those 4 files. Then what happens if there is another version? So data changed in my Parquet file. There is another version. I don't have idea here that this version exists, right? So I need to refresh the data. And when I say I need to refresh the data, I need to expand my frame and tell Power BI, look, there is a new version over there in one lake. Go and include this one also in my frame. Okay? And now I have all five files, all data from all 5 files available in my semantic model. Keep in mind that this operation only refreshes metadata. So this is just for Power BI to be informed that there is a new version of the file. Physically, data still stays in one lake. That's to answer the Bernard's question. But Power BI now knows, okay, there is a 5th version of this file. When I need data for my queries, I will go and pick up data from 5th version of the file. That's how direct lake works. And in this example here, what I did, I made a change to my dim customer table. You see there is a new version of the file over there. And in Delta log, this one will be shown as a latest version. So this is a Delta log. These are 2 versions of Parquet files. And Power BI will now read, once I refresh my semantic model, it has information about this version of the file. I hope that makes sense. This is important because this is a key difference compared to import mode. So with framing or refreshing direct lake models, it doesn't refresh physical data in the model. There is no physical data in the model, right? So it's just a metadata. And why is this important? With the import mode, when you click refresh, if you do a full refresh, it will go and pick the entire data set in the entire semantic model, sorry. So all the tables and do a full refresh and physically move this data into Power BI. Here, there is no physical data movement. It just refreshes metadata. And this is why, even though if you have billion row table, this process of refreshing semantic model in direct lake on a billion row table will not take you more than 1 minute, probably, maybe even less than that, because it's just metadata. Remember, not physical data. You're not moving billion rows and refreshing billion rows. You just refresh the metadata. And that's why this process of having the latest data available is much faster in direct lake compared to import mode. So to reiterate key concepts that exist and that are relevant for direct lake, I like to visualize things. So first we talked about syncing. Syncing means when new table arrives into one lake, what should I do with this table? Should I automatically sync my semantic model, or should I manually do this? So that's the first consideration. Then we have this process of framing. That is the process of adding the information about the latest version of the data to your semantic model. Remember, it refreshes only metadata. Then we have a paging, which I will show you in a demo very soon. Paging is a process that loading columns needed by query into a cache memory, similar to what happens when you are using import mode. And we have a concept of temperature. Again, I'll show you in a demo. That is the process, or that is the feature that exists in tabular model. So it's not strictly relevant only for direct lake mode. It's relevant for tabular model in general, which helps the engine to keep frequently used columns in cache memory. So let's go and see how these two work in real life. So let's start with import. So what I have here and what I prepared, just to give you a little more of a background. So I have two identical semantic models, identical data. Note all relationships, all columns, all calculations, everything is absolutely the same. Fact table contains 220 million rows. So it's not super huge, but still it's not small. So you see the difference in certain things when it comes to performance. So just to show you, I have a perfectly designed star schema with my fact table in the middle and all dimensions surrounding it. And as I said, the model is the same. So what happens if I start creating, let's create a simple table visual, and I'll drag, let me first turn on my performance analyzer and start recording, and I'll pick year and I'll pick row count. So this is import mode. Okay, here is my query. I can go to DAX Studio. Where is DAX Studio? Here it is. This is direct lake version. So I have this one is, I think, no, this one is for direct lake. Where is my, probably this one? Yeah, this one is for import. And then I can run this query. Hopefully I didn't lost connection in the meantime. Yes, I did. So let me just quickly reconnect. And go to my import model. And let's turn on server timings. And let's run this query. So there is one storage engine query. Obviously, it's something is not valid here, I would say. Let's try again. It's not possible to be 0 milliseconds. Let me try to reconnect. Sometimes DAX Studio is just, or maybe I can refresh metadata. Let's try again. Okay, this doesn't want to cooperate. But yeah, never mind. Going back to show you how it works from direct lake. So here we had like almost 7 seconds. But what happens now if I include, for example, total number of total claims? It's much faster. Why? Because data is already in memory. So with import mode, data is already in memory, and then whatever column I add, it's much faster. Probably some of data is also cached. So if I do the same thing here in my direct lake version, so in this case, again, the model is the same. It's now just direct lake semantic model that I'm using. And let's turn on performance analyzer here, and let's do the same thing. So here, and we had row count, and we had, let's wait, we have total claims, and we have total drug cost. So depending on the column size, and if the column was used previously or not, it can produce, as you see, of course, this is not like 100% reliable test. We need to run like benchmark multiple runs over our data to get more reliable results. But from what I've tested so far, the first run can be slower in direct lake compared to import mode. And this is happening because data is not in the memory. And for this first retrieval from one lake, what the engine needs to do is to translate this data from Parquet files into this format, which is stored in the VertiPack. But all subsequent queries, and once the column goes into the VertiPack in memory, even with direct lake, so in direct lake, these columns are stored within the VertiPack in memory. All subsequent queries behave exactly the same like we did import mode. Potential difference is that if the VertiPack is able to better sort the data than you are able to do, or the engine is able to do when you are writing data with vOrder into direct lake, into one lake. But knowing Microsoft, I think that's the same algorithm in the background. So I guess that's the same thing. So once the column goes from one lake into the VertiPack, it's essential import mode. Nothing more, nothing less from technical point of view. Now I told you I prepared also for paging, and for paging I have...
Wait, Nikola, there is
yes.
a question that might be interesting to address now. Here we have Dan Voronin saying, but the direct query is dependent on the underlying power of the database, hardware, and latency bandwidth. Using Power BI Desktop and other apps, and your PC, laptop limits you with the amount of RAM, CPU, SSD, etc.
Direct lake or direct, or Dan?
Can
you just direct query is dependent? Direct query, yes.
Yeah, so
direct query. Yeah. Go ahead.
So
sorry.
when you're actually presenting this comparison, when using your laptop with some application running, you actually limit it with your laptop or PC power, like in terms of CPU and memory allocated. So this is one limitation when you're using your laptop to operate with in-memory data. On other hand, when you query in the very powerful database with very good bandwidth allocated between you and actually the database, the direct query will be very fast. And I actually specialized last 6 months doing these comparisons in our company with playing with middle and big amounts of data.
Okay, so you just to confirm that I understood that direct query performs better than in-memory query.
Yes, of course. We have something like a green plum MPP engine, which is like a clustered green plum, very powerful, and it's capable to to construct on these chunks of data across different segments of green plum into one chain in very fast mode. And then if you have a good bandwidth between your laptop, let's say, and the database, you will get the data in very fast mode. While comparing when you're doing for example, joins using Power BI Desktop and your memory of your laptop, this was very, very slow and producing many kinds of errors, especially when working with something else than SQL Server, especially.
Okay, so yeah, I mean, there will always be edge case where direct query performs better than import. There will be edge cases, but I think we can agree, and we should agree, that in 99% of cases, direct query will be slower, significantly slower than import mode. So I think
that all depends on your hardware underneath. And again, if you're talking not about like Power BI desktops specifically, but talking, let's say, about data flows or something running in the Microsoft cloud, again, you are limited with the power of you actually virtual machines allocated for you with premium capacity. And it's, again, as you can see, I mean, I saw that performance is not, is not terrific, to be honest.
Okay, so yeah, I mean, if it, yeah, okay, I get your point. That's I respect that. So, but from my experience, and yeah, I would say, if we ask people who work with Power BI, I think most of them will tell you that for most of the use cases, import is faster than direct query. And I think that's a fact, and that's a measurable thing. As you said, there will be situations where direct query probably performs better, same as there will be situations where one flat table will perform better than star schema, but that is more an exception than the rule, I would say. But thanks for sharing this experience. It's interesting and good to know.
There are also many other cases when I could say that Power BI probably wasn't the best choice. And I could actually explain many cases when, many specific cases when we saw like kind of issues or constant issues, especially when working with something else than SQL Server. SQL Server is adapted for SQL Server completely. Yes, I would agree.
Okay, yeah, sorry for interrupting.
Yeah.
Can we continue discussion offline, please? Because because of the time.
Thank
but
you.
Yeah, thank you.
For
Thanks.
answer.
Thanks. No problem. Okay, so the point here that I wanted to show is that once you bring the data from one lake into memory, it behaves the same as with import mode. Here I prepared a few, so let me just connect to my direct lake model. So here I prepared a few queries that retrieve data from dynamic management views that you can use to see which columns are most frequently used. Remember, we mentioned concept of temperature. So in this case, I'm using year in my table. I'm using total claims. I'm using total drug cost, just to show you. I think it's here. Yeah, so I'm using year, total claims, total drug cost. And if you take a look here, those columns have the highest temperature. So that's how the engine decides which column should stay in memory. Of course, memory is a limited resource in case that there are many noisy neighbors trying to also query some data. The engine needs to balance this and define which columns will stay in memory or which columns go out of the memory. So once there is not enough space in memory, some columns will be kicked out. That's the first thing that may happen when you work with direct lake. And then when the column is kicked out from the memory, it goes back to one lake. So for every subsequent query that needs data from that column, it will be slower for the first run until the temperature goes again high, and then it will be stored in memory, and again all queries then will be faster. If I execute this one again, you'll see now it's 21.5, 19.8, and so on. So this temperature slowly decreases if no one is using those columns in the report. If I go back to my Power BI desktop and I click on a slicer or whatever I do with my report, this temperature will again go higher. That's the concept of a temperature. Then we have a concept of residency. So which columns are paged in memory. So this one, again, you have an information about the temperature, but in this case, it shows you which columns are currently paged in the memory. So whenever it says true, you saw year is paged in memory because of the high temperature. This one, year date key, because no one is using it, it's not, and it has very low temperature, it's not paged in memory. So it's in one lake. In case I now use this year date key in my report, then this one will go and become a resident of a memory. That's how this whole process works behind the scenes. Here I also prepared two things, but I don't want to bother you now, how to measure the size of your data model. And this is also very, very interesting. So the one thing that can reset your direct lake model is not using columns at all. Another possibility is that you refresh your data model. So let me just find my, okay, here it is. I need maybe to, this is so annoying with PowerPoint slideshow, where it is. Okay, let me do it like this, it's easier. So if I go back to my data model, this one, direct lake, and then I hit refresh here. So this is how you refresh the direct lake model, same as with import mode, but this one will probably take significantly less time. So probably like maybe 30 seconds. Or no, so you saw it was like 5 seconds, and we have 220 million rows in the table. So what happens when I refresh my semantic model? All the data that was paged in memory goes out. So that's why it is important to keep in mind if you do this automatical refresh of the data from one lake all the time data will be kicked out from the memory. And what happens? Let's go to DAX Studio. This one is direct lake. So if I open my VertiPack analyzer, let's see the size of the data model currently in memory. Let's see what happens. Is it okay if you go like maybe 7-8 minutes above 8?
That's perfect. It's okay.
Thanks. Thank you. So what is the size of this model? 46 kilobytes. 46 kilobytes. As I said, nothing is in memory right now. So I reframed my semantic model, direct lake semantic model. Nothing is currently in memory. And this is 46 kilobytes. This is just the metadata. And if you take a look at our another one, which is import mode, maybe I need to reconnect. So import mode, and let's go to VertiPack analyzer. Summary, it's 4 gigabytes. So 46 kilobytes versus 4 gigabytes. But as soon as I do something here with my direct lake report, let's say I add this one, total day supply, and let's go again to DAX Studio for this one is direct lake. And if I click on view metrics again, now some columns go into memory, and the size of this one also goes to 4 gigabytes. So now it loads all the columns into memory. Few more things to cover. That's why I'm going back to presentation. What happens when direct query cannot be executed for whatever reason? By default, your queries will fall back to direct query. So there are certain guardrails to prevent some resources, burning some resources. So this is a table from Microsoft's official documentation, which shows different limitations in terms of guardrails and when your direct lake queries will fall back to direct query. This max memory is interesting because that's the resource limit for how much data can be paged in for each query. So it's not per model. It's not a memory of your entire model. It's memory for a certain query. And there is maximum model size on disk, or in this case, disk is 1 lake. This is the limit beyond which all queries will fall back to direct query. If you use smaller SKUs like F2 to F32, there is a certain limit of this max model size in 1 lake. If you use F64 and above, then it's unlimited. But also keep in mind rows per table. This is also a hard limitation. You can always use this dynamic management view to see the fallback reason. If it's 0, that's great, because then direct lake works. If there is another number that is not 0, then it's falling back to direct query. You can change this default behavior. As I said, by default, this automatic, there is a property which is called direct lake behavior. You can access it both from Tabular Editor and Power BI Web UI. And you can change this behavior. So by default, this automatic one will tell Power BI if there is no possibility to use direct lake, then execute my queries by using direct query mode. You can also set it to direct lake only. Then if there is no possibility for direct lake, you will get an error. And finally, direct query only means it's always direct query only. As we said, from Web UI or Tabular Editor. Some final thoughts about direct lake. Limitations. Again, keep in mind as of today. So things are also changing here. You can query just one single lake house or warehouse. So if you have data across multiple lake houses, you either need to bring it into one lake house, either physically or through shortcuts, whatever, but it's limited just to one single lake house or warehouse. No DAX calculated columns and calculated tables. Although I think I saw that calculated tables are maybe supported now. I need to test this, but calculated columns are for sure not supported. No composite model, so it's direct lake or nothing. You cannot create relationships on date time type of columns. And currently, as I mentioned, web modeling only or Tabular Editor for managing your semantic models in direct lake. You can just build the report from Power BI Desktop. Here is the link to current limitations in Microsoft documentation, and I think I will share with Bernat this presentation. So please always check what are the current limitations at the moment you plan to apply direct lake mode. Some benefits of direct lake mode: performance is really comparable to import mode. So it's not just this demo. I'm currently working with a client. They have like data sets of 200 gigabytes, a few data sets around between 150 and 200 gigabytes with billions of rows, and performance is really comparable to import mode. It's possible also to eliminate the serving layer if you use something for your, let's call it gold layer, because it's nowadays like a general accepted naming convention. So if you use something like Synapse or Azure SQL DB, now you can completely omit this part and of architecture and save some costs probably. Refreshes in import mode, as we know, they really refresh your physical data in the instance of analysis services and may use a lot of capacity units, whereas with direct lake you refresh metadata only. Multiple models can use the same Parquet file with shortcuts, and this one is more not just for direct lakes specifically benefit. You can also enable other people from your organization to leverage data from a same file in one lake. To wrap up, direct lake is a fantastic feature. There is no single discussion about that. But direct lake also is not one solution to rule them all. Absolutely not. If you are happy, this is my personal opinion. Of course, you will not find this on Microsoft's documentation or whatever. If you are happy with your existing import models, don't switch them to direct lake for the sake of switching. At least not yet, with all of these limitations and other things. If you are happy, keep using them. Now the question is then, when should we use direct lake? I would say if you already have data in a lake house, does it make sense to then create another copy of this data from a lake house in semantic model in Power BI if you use import mode? Or does it make more sense to directly query this data from one lake with performance which is almost the same as with import mode? So for greenfield lake-centric solutions, I would say direct lake may be the default choice, maybe. And yeah, but all in all, this is very new concept, and we are accustomed to working with Power BI in previous years in a certain way. So it's not easy to just switch our mindset and switch our solutions and best practices over the night. So we are all still learning when to use Direct Lake. That's my honest conclusion. And with that being said, that's it. What I prepared for this session. And yeah, happy to answer any other questions.
Yes. Well, thank you. I mean, I'm pretty much onto what is going on in the Power BI world, but there's quite a few things that I didn't quite grasp, and this presentation really made them very, very clear for me. And I really appreciate the effort you put and the time you put to explain us about them.
Thank you. Yeah,
really
happy to hear
clarifying.
that. Thank you.
I mean, yeah, you were mentioning like if you have a lake house, then maybe it's a direct lake, maybe not. And one possibility, and I think that there's some people in our group that has worked in that use case, and is if it's a very small company, that maybe they just starting with Fabric because it's easier to set up a notebook and load data from an API or something like this. Then you can have a lake house and to write all the data, which is the easiest way. Then if you import the data into a pro workspace, then you can turn off the capacity and save some cost.
I mean, there are tricks, of course. There will always be some tricks to do. Of course, every use case is individual and specific. So, as I said, there is no one solution to rule them all. Not just regarding Direct Lake, but generally speaking, in terms of working with data. You will always find some piece that can be maybe done in a different way or using different approach. And I agree. There are nuances to figure out for every.
We have Fernando. He has some question. You probably wrote. You read that article from Marco that he was saying that Direct Lake is maybe useful for like 2-3% of the models. What is your stand on that?
So in my current client, I will tell you it's not 2 to 3% of models, it's 70 to 80% of models. So for them, yes, because they have like 10 models, 7 of those 10 models are really huge and data is already stored in a lake house. So for them, Direct Lake is way more practical approach. Lifesaver, way more practical approach than combination of import direct query with aggregations and stuff like that. So it depends. 2-3% is a relative thing. 2-3% maybe for someone of you who are working like Dan mentioned for this direct query use case. For him, direct query is better than import, right?
Indeed.
But then maybe it's just 2 or 3% cases, but it's still for his use case it's better. So
I know.
Same for Direct Lake. It will be better. It depends on. I would not be. I can't agree with this number 2 to 3% because it really depends. It really depends.
Makes sense.
Yeah.
What I'm missing, I don't know. It would be a hybrid approach on top of Direct Lake because maybe you have a huge table, and if it's so big, then right now it says, oh, too big. It's gonna be direct query for you. But say, hey, but maybe I have a lot of data, but I really want the last 2 years in Direct Lake. And then if I query something further, then it could be direct query.
Yes, like hybrid tables,
Yeah, like hybrid tables, but for Direct Lake.
Yeah. Oh, I love that. I love that idea. Yeah.
That would be nice because I did have a project and we had this huge model. We were running on PPU, so there was no Direct Lake there. But I was thinking because this was developing, as like, hey, if everything fails, maybe we should go the route of Direct Lake. But then I realized that maybe not because there was this limitation, and then maybe then you need like an F64 or something, which would be completely much more expensive.
Yes, I mentioned this client multiple times. So they have a table with 9 billion rows. Whoa. So they cannot go below F512 because there is a hard limit of number of rows. If I go back to this table that I show you. So
that was surprising for me. Like, really, why would you do that? Yeah.
They have 9 billion rows. This is the number of rows in millions. Rows per table. So if a table has 9 billion rows, you can't use anything below F512.
Wow, it's a P4.
So
oh, that's expensive.
Yeah. yes, but they have a lot of data and they want
a lot of money as well. Yeah.
Yeah. I mean, don't blame them for this.
No. Lucky
no,
them.
just kidding. Of course, yeah, of course. Just kidding.
Yeah.
But there are use cases. There are use cases. Obviously, there are use cases.
Wow. Well, thank you. I think it was a great session, and I thank you again for doing it.
Thank you for inviting me.
Yeah, next time in person, please.
Hopefully, hopefully. Fingers crossed. Yeah, fingers crossed.
Are there any consumption on CUs with direct lake? Well, yes, right?
Yes. Yeah. All Fabric workloads, whatever you do with Fabric, there is a CU consumption. So this process of taking data from one lake to memory, it consumes capacity units.
And compare with direct query, is there a difference, or is just performance?
In terms of usage of CUs, I can't tell you, so I didn't test that.
Yeah,
so I really don't know. Yeah, I really don't know.
I mean, the data is the same volume, so it's.
Who knows? Yeah, who knows what happens really in this transcoding process? Yeah.
Okay, somebody test and write a blog, please, about this. Yeah.
Yeah. I will read it for sure.
Okay, so let's wrap it up, and so I'll just say goodbye to everyone. Muchísimas gracias a todos. Ha sido una nueva sesión de PUG Barcelona. Tenemos a Nikola. Vamos a darle un aplauso ahí con las reacciones, que esté contento. Realmente yo creo que ha sido muy informativa y me ha gustado mucho cómo lo ha hecho, la verdad. Well, thank you. Nikola, you can now continue your live. Yeah, you're welcome.
Muchas gracias. Thank you, everyone, for joining.
Hasta pronto. Bye.
¿Qué diría Puigdemont?